In today's lesson, we are going to be looking at solving two-step or multi-step equations. When you have an equation and you have a number missing, we represent it with a variable. We're trying to figure out what number goes into this spot. So we're solving for this variable. In order to do this, we're going to think about PEMDAS. If you remember parentheses, exponents, multiplication and division, addition and subtraction, we solve equations using this. In order to solve for a variable like this in an equation, we're going to actually do PEMDAS in the opposite order because we're undoing it. So we're going to do the addition subtraction first and then move up. So if we look over here, the first thing you're going to do is you're going to locate the variable. Here is the number that we're looking for. So you're going to move everything that's on the right side of the equation over to the left side to get the variable by itself. Now if you look here, x is being multiplied by a -2 and it's being added to 6. So we're going to move what's not attached to the variable first because of the adding 6. So we're going to subtract 6 on both sides first, which we'd be doing PEMDAS in the opposite direction. So what does that look like when we subtract 6? Now remember that what you do to one side of the equation, you must do to both sides of the equation to keep both sides equal to each other. So here if we subtract 6 from both sides of the equation, we're going to have 4 left on the left side, and the 6 minus 6 becomes 0, so it goes away, and what's left is a -2 times x. X is still not by itself, it's being multiplied by a -2. The opposite of multiplying is dividing, so we're going to divide both sides by a -2. On the right side, a -2 divided by -2 is just 1. Well, 1 times x is just x. On the left side, we have 4 divided by -2, which is a -2. Now we can go back and check this to see if it actually is correct by plugging in. We think the number missing right here is -2. So if we plug that back into the right side of the equation, that would give us 6 minus 2 times a -2. Now since we're solving, we do PEMDAS in the correct order. We're not undoing, we're solving. So first we do the multiplication. So that would give us 6 plus a +4, and indeed that does equal 10, which is what we started with on the left side of the equation. So it does check. This also works for decimals or fractions, so we're going to look at some examples of that. First, we locate the variable. We want to move everything that's on the same side with the variable. So we want to move the 1 2/10 and the -5 7/10. We're going to move the one that's not attached to the variable first, because here is where the addition or subtraction is. That is a -5 7/10. So in order to move it to the left side of the equation, we have to do a +5.7 on both sides. That becomes 0. So on the left side, we have a 1 5/10 plus a 5 7/10. That is going to give us 7 2/10. On the right side of the equation, we still have a 1 2/10 times y. This is multiplication. The opposite of multiplication is division. So we're going to divide both sides by 1 2/10. And 7 2/10 divided by 1 2/10. So it's dividing by it. That becomes 1, is just 6. Then we can plug that back in to the original right side of the equation to see if we are going to get 1 5/10. So when we plug that in, we have 1 2/10 times 6. We do the multiplication first, which is 7 2/10, and then when you subtract 5 7/10, you do indeed get 1 5/10, so it checks. Here we locate the variable. This time the variable is on the left side of the equation, so we want to move the -10 and the 5 over to the other side to get the variable by itself. We're going to move what's not attached to the p first, so we have a -12. So to move it to the other side, we do the opposite of a -12, so we're going to add 12 to both sides. A -12 and a +12 become 1, or it becomes 0, I'm so sorry, and it goes away. So then we're left with p divided by 5. This time the variable is being divided by 5. So we want to do the opposite of dividing, which is multiplying both sides by 5. What does that look like when you multiply both sides times 5? That means here on the left side you have 5 divided by 5, which is 1. And 1 times a variable is just that variable. On the right side we have 32 times 5, and it has 160. Again, we can go back and plug that in. Since the variable was originally on the left side of the equation, we can plug it back into the left side of the equation, and we would have 160 divided by 5 minus 12, which is 32 minus 12, which equals 20, which is what we wanted it to equal, so it checks. This also works with fractions. We locate the variable. We're going to move what's not attached to the variable first. That is a negative 1/5. So we're going to do a positive 1/5 on both sides of the equation. So 3/5 plus 1/5 is 4/5. And of course the negative 1/5 and a positive 1/5 becomes 0, so it's gone. Now we have the variable being divided. This is divided by 15. So now we're going to multiply both sides times 15. And with a fraction, that would be the same thing as 15 over 1. Now if you look over here with this, you'll see that we can do our cross-canceling to make our life easier. 5 and 15 are both divisible by 5. So that would be 1 and 3. And that gives us 4 times 3 on top. And 4 times 3 is 12. Show that again here. There's multiplying by 15. Those cancel out. I did not show that, so here's the 1. Here's the 3. So all you have on top is 4 times 3, which is 12. Now if we plug that back in to the equation on the left side, we would have 12/15 minus 1/5. Now if you remember, with adding and subtracting with fractions, you have to have common denominator. So we're going to rewrite 1/5 with a denominator of 15. Or we could have simplified. We could do it either way. We could do 12/15, and you could rewrite that as 3/15 and simplify after you subtract. That would be 9/15, and then you could subtract. Or since this fraction could be simplified and it happened to simplify to a denominator of 5, you could simplify that first, which gives you 4/5 minus 1/5, and that's going to give you 3/5, which is the same answer. So you can simplify first, or you can simplify later, whichever you like. Now this is where we're going to move on and start having multi-step equations. If you look up here on the left side, we have the variable twice. So we have something that we call like terms. They're like terms because they have the same number being multiplied by both of them. X is the same variable. That means the same number is being multiplied by both -8 and a +6. So what we're going to do is we're going to combine or add like terms first. A 6x and a -8x is a -2x. Plus 3 equals 13. So far all we did was combine these two. And now we have our two-step equation. So you locate the variable. You want to move what's not attached to the variable first, which is a +3. So we're going to subtract 3 from both sides of the equation. And that gives us a -2x on the left side and a +10 on the right side. Now we divide both sides by -2, since the variable is being multiplied by -2. And that gives us a -5. Now if we plug that back into the equation, it looks pretty long, but we had to plug in the -5 being multiplied times the 6 and times the 8. So now we follow PEMDAS because we're solving an equation. We do the multiplication first, and that would be a -30 and a +40, and then when you add the 3 together, that gives you 13, which does check. Now this might look a little different. We see parentheses. When you have two terms inside parentheses, or 3, we're probably going to have to do the distributive property. That's what you have to think. When you see a set of parentheses like this, and it has more than one term in it, you have to think distributive property. The tricky thing about this one is you don't see a number right here. If you don't see a number right here, it's an invisible 1. So basically we're doing the distributive property. So we're going to multiply -1 times each one of those terms in the parentheses. That has to be our first step. So -1 times x is a negative 1x, which is the same thing as negative x. And negative 1 times a positive 2 is a negative 2. So I did the distributive property. Now, where the variable is, I locate the variable. I notice that there's two what we call like terms. Neither one has a variable attached, so they're like terms that we can combine. And 6 and a negative 2 would be 4. So now we have 4 minus x. We still want to get the x by itself, so we have to move the 4 to the other side of the equation. So we subtract 4 on both sides, and that gives us 5, but our x is negative. See the negative x? That means we have 5 equals a negative 1x. We don't want our variable to have a negative in front of it. So to do that, we simply divide both sides by a negative 1, and a negative 1 divided by negative 1 is a positive 1. Now our variable is positive, and it's equal to negative 5. So x is equal to negative 5. If we were to plug that back in there, we would see that we have right here, we can go ahead and do our parentheses first. So the 6 minus a negative 3. And when you have minus a negative, click, click, or you add the opposite, and that would equal 9, which is what we wanted it to be originally on the left side. So watch for the distributive property. Again, here we have the distributive property. We see a set of parentheses with two terms in it, so we have to multiply 4 times each term inside of that. 4 times x is 4x, and 4 times negative 2 is negative 8. Now, if we look where the variable is, we have something we call like terms that we have to combine, because on the left side of the equation we have two terms that are x variables. 4x plus 2x is 6x, so we have 6x minus 8 equals 40. We locate the variable. Now we're down to our two-step equation. We have to move what's not attached to it first. That is a negative 8. So we add 8 to both sides of the equation. That gives us 6x is equal to 48. We still do not have x by itself. We're going to divide both sides by 6, and that leaves us with this x is equal to 8. Again, we could plug that back in to check. We have a set of parentheses here. We can do parentheses first. That would be 4 times 6 plus 16. That would be 24 plus 16, which is equal to 40, which is what we wanted it to be, so it checks. So again, here you'll see that we have the distributive property. So the first thing we're going to do is multiply 3 times both terms in parentheses. 3 times negative 10t is a negative 30t. 3 times negative 3 is a negative 9. Distributive property first. Next, find the variables, and we notice that we have what we call, again, like terms that we can combine. We have a negative 30 and a positive 6. Different signs subtract, so that gives us a negative 24t when we combine them. Now we have our two-step equation. We locate our variable. We move what's not attached to it first. So we're going to add 9 to both sides of the equation. When we do that, we have 84 on the left side equals a negative 24t. T is still not by itself. It's being multiplied by a negative 24. The opposite of multiplying is dividing, so we're going to divide both sides by a negative 24, and that gives us a negative 3 5/10. Sometimes our answers may be decimals. Again, we can plug that in. When we go through the steps, we will see that it checks. So you can always go back and check it to see if it works out. The rest of this problem solving we're going to do in the next lesson. So that ends the notes for today. I hope this was helpful.